Hello, what I did when I stopped the video is that I put some reference points in here. So again, this is the data we had on the previous side where we got the elasticity to be 2 1/7. And then I plotted $40 and 100 units right there. That's where we start. And then we raise our price to $60 and now we're selling 40. And so I can connect those two dots and that will be, I can't connect the two dots. Oh my goodness. Try again. Connect the two dots. There we go. And so that represents our demand. Now let's look at the total revenue. Total revenue is price times quantity. Total revenue is price times quantity. Quantity demanded. And so the price is $40 times 100. That gives us $4,000. And that actually is the area right here. Let me maybe get like a blue pencil. And so $40 right here times 100 would be this area right here. All this would be my total revenue. It's actually a rectangle. Area of a rectangle is base times height, right? And so the base here is your quantity demanded, your height is your price, and so base times height will give you total revenue of this area right here, which is $4,000. Now what happens if we raise our price to $60? So it's $60, total revenue now is going to be $60, which is a higher price, that's good, but now we're going to be selling 40, we're selling less. And so, because my math's a little shaky right now, let me get my calculator out to make sure I get this right. 60 times 40 would be $2,400. And that'll be this area right here. So the revenue here is going to be taller because you get a higher price. That's a good effect, but it's going to be not as wide. It's going to be more narrow, which is the bad effect because you're going to be selling less because we're going from 100 to 40. And so this is why your revenue is going to go down, which indeed went down from 4,000 to 2,400. And that is because we lost this amount here. This amount here is what we gave up. That's the bad effect of selling less. And this is what we got for it. This area up here. This part in here, like that, maybe orange. Looks like orange. This part here we kept. These other customers we kept. So we kept our 40 customers here out of 100 that we started with. We lost these customers here as they went somewhere else. We lost this money here that they would have spent at $40. We kept these people here. They're going to be paying the higher $60, and therefore we added $20 a piece to these people here. And that's a problem when you have elastic demand. You raise your price, you get some additional revenue from your remaining customers, but the problem is you lose a lot of customers. And so probably not a good strategy to raise your price here because your revenue is going to go down. Now what would happen if your demand is inelastic? Well, if it's inelastic, then the whole thing changes. There's still a good effect, which is the higher price, and the bad effect, you sell less, but now it's switched. Now the bad effect, the decrease in the sales, quantity demanded, is now smaller. So this is the effect that, and so price, this effect, it's going to have a bigger impact on our revenue than the lower sales we have here. So in this case, we're going to lose some customers, but not that many. And so if we raise our price, then we're going to keep most of our customers and we bring in more money. A good example of this would be Disneyland. They've been raising their season passes and their one-day admission prices pretty continuously over the last 15, 20 years, and they just keep making more money. Why? Because they don't lose any customers, or they lose very few customers. Disneyland has a problem where they have too many customers, and actually they're trying to get rid of some of them, and so they keep raising in their season passes and their daily admission fares, and they don't lose their customers. They keep coming. So that's going to look at another example here with numbers. And before I want to show you the graph here, I want to make sure that these are inelastic. And so now let's take the change in the quantity. Here we're going to have the same price and quantity starting with, but now we're going to raise our price to $60, and now we're going to lose sales down not to 40 but to 80. So in this case up here, sales went all the way down from 100 to 40. Now they're going to go down not nearly as much, and that is what inelastic means. You have a smaller change in your quantity demanded. Let's make sure the numbers say it's inelastic, and so now again the change in the quantity would be 100 to 80, that's 20. The average is going to be 180, which is 90. So 20 over 90 is 2 over 9. And this would be the same here in terms of the prices. I didn't change the prices, and so it's still going to be 20. It's going to be the change, and then the average of 1640 is going to be 50. And that'd be 2/5. So now we have 2 over 9 over 2 over 5, which is equal to 2 over 9 times 5 over 2, which is equal to 10 over 18. And if I divide both by 2, that'd be 5 over 9, right? 5 ninths. So less than 1, definitely inelastic. Let's look at the graph. Here I pre-plotted the points. Let's see if I can draw my line for these points here correctly. That one did much better. And so now we'll label this demand. And again, our revenue is the same starting out. It's going to be the same number. Total revenue is going to be $40 times 100. And so that's still going to be 4,000 we're going to start with. Again, that's going to be this area here. And now when we raise our price to $60, we have total revenue is 60 times not 40 but 80. So it looks like it'd be 4,800. Let me double check. 60 times 80 would be 4,800. So in this case, we started with the same price and quantity, but now we actually can increase our revenue if we raise our price. And so now this is the total revenue after we raised our price. So again, the part we lost is this blue part here. You can see it's much more narrow, not as wide, because we didn't lose that many customers. And that's a bad effect. We lose this money here from 20 customers we lost. But we don't care. We kept 80 of our customers, and they're paying 20 bucks more a piece. So now it's a good idea. We're going to trade this blue part here for this part up here. And this area here is more than that, which is why it goes from 4,800. Sorry, from 4,000 to 4,800. This part here is the customers we kept. And the reason why we're making more money is that these customers, I would call them suckers maybe, I don't know, depending on what we're selling. These are the people going to Disneyland. They're willing to pay the extra $20 a piece. And so now our red and orange part here is our new total revenue, which is greater than the blue and orange part down here. And again, what happened is that we traded this part here for that part there, which is why it went up. And this actually means more profit, because if anything, if I'm going to be selling less, if I have less customers coming into Disneyland, then my costs of anything have to go down. I mean, if I'm having less customers or manufacturing less chairs or something, therefore, if anything, my costs definitely won't go up, and most likely they're going to go down. So if I can bring in more revenue, at the same time my cost stays the same or even goes down, this means my profit will go up as well. So if you have an inelastic demand like Disneyland has, you raise your price, you can keep driving up your profit, which makes good economic sense, good business sense. And that's the benefits, the biggest benefit of having an inelastic demand if you can control the price. If you can't control the price, then inelastic demand actually can become a problem, which I'll talk about later on. Okay, got a few more minutes here. Let me sum up here about revenue and elastic demand, inelastic demand. So bottom line here, total revenue and elastic demand. If it's elastic and you raise your price, we talked about this, your sales go down, but they go down a lot. So here your revenue is going to fall. If you have a demand which is elastic, you might want to drop your price. If you drop your price, you're going to sell more, and you're going to sell a lot more, because again, customers are quite responsive to your price change. And this is Walmart. Walmart, what they do is they live with low prices and they make a little bit of money on everyone they sell, but they sell how much? A lot. And so if price decreases, they lose money on everyone they sell, but they sell a lot more. And this could actually make your revenue go up. I'm sorry, will make your revenue go up if it is elastic. Now you've got to be careful. It doesn't mean your profit's going to go up because, again, we're selling more. And so if Walmart's selling more, their cost goes up, so I'm not quite sure if they're making more money or not. So they have to be a bit more careful in terms of maybe more analysis and do how much the cost is going to increase. If their revenue goes up by more than their cost, then definitely you want to drop your price. Inelastic demand, we just saw that. If you raise your price, like Disneyland, you're going to lose a few customers. But you make up for that in the higher price. And so everyone you sell for a higher price, and you don't lose that many customers. I don't think Disneyland can lose any customers. And the revenue just goes up. And again, if revenue goes up here, that means profit goes up. Because if anything, your costs have gone down or have remained the same, and that means more profit. On the downside is if the price decreases. Price decreases, you're going to sell more, but not that much more. And therefore, this is actually going to drive down your revenue. And because you're selling more, lower revenue and because you're selling more, your cost has probably gone up, and so lower revenue and higher cost most likely means your profit's going to go down. And let me stop there, and I'll give you an example of a situation where you have inelastic demand, but you are a price taker. Disneyland is a price maker. They have no problems with this. They like this. But if you're a price taker, you're in trouble sometimes.